vehicle engine or in general IC engine, when we are talking, uh, basically focus is there. Engine should be energy efficient, fuel efficient, it should be compact, and it should be having low emission. So these 3 points right now, designers and researchers in the area of engines, they are focusing. So first we'll discuss interfaces, various interfaces where friction is coming in the picture. So a sectional view, schematic diagram of IC engine is shown, and interfaces, when we are looking, basically heart of the engine is piston ring and cylinder liner, or we can say interface of the cylinder liner and piston ring, that is heart of the engine. And the way human being heart works properly, then everything is fine. Exactly same thing is there in the engine. If piston ring and cylinder liner interface is working properly, things are perfectly fine. Uh, in order to quantify friction in the IC engine, here one typical example is being given. So this engine data has been taken from one journal, Tribology International, published in 2004. If we see the breakup of the energy, because when fuel is getting burned, chemical energy, it is being converted to mechanical energy. So for a typical engine, this distribution, it is shown like this: 60% of the energy means chemical energy. If suppose single drop of the fuel, it is getting burned, then 60% of energy is waste through exhaust and cylinder, etc., cooling. And 50% energy, it is being lost in friction, and 25% energy, it is available as brake horsepower. Now this is not valid for all type of engine. This data is valid for one typical engine where researchers have done experiment and they have quantified it. So this range may be varying engine to engine, but one thing is very true, that significant energy is being lost against overcoming the friction. So if suppose somehow part of this energy, 15%, some part we save, we convert in useful work, or some part of this energy is being added in brake horsepower, then efficiency of engine will be enhanced. Now 15%, whatever power loss is there, if suppose 15% we are presuming 100%, and then breakup is presented for the engine right now in the context, then we are looking this breakup, 45% of the energy, it is lost at the interface of the piston ring and cylinder liner and assembly, and 25% energy, it is being lost in the bearings, and similarly 20 and 10% energies are being lost in pump and valve train. So if we are focusing interfaces of the various components like bearings, piston ring and cylinder liner, valve train, and we are minimizing this loss, then efficiency of engine can be enhanced, fuel efficiency can be enhanced. So right now the talk is basically at the interface of piston ring and cylinder liner. So we are focusing at this point. Now see what is happening. Let us see the function of the interface. So at this interface, cylinder liner and piston ring, so the function of the piston ring is basically, if you see, it is a sealing, combustion product being sealed by the top compression piston ring, and top compression piston ring is a barrier. Its role is very crucial. The reason is lubricant from downside is going to the upside, so it may pass to the combustion chamber if proper design of interface is not there. So both way it is crucial. If exhaust gases are passing through the interface, then also it is problematic. Efficiency will go down. And if fuel lubricant it is going up, then also it is a problematic. It is not economical. So design of the interface should be proper. Now second ring, if we are looking, so basically second ring it is also a compression ring or pressure ring it is. So objective whatever it is having basically to scrape the oil, it should not go towards the combustion chamber side, and downside third ring it is oil ring, so it is sending the oil back to the sump. Here issue is why this interface is very important. So let us play one video in order to understand the phenomena at the interface. So here piston ring surface it is gliding over the cylinder liner. So if under dry contact gliding or sliding is taking place, then it is not preferable. The reason is friction will be very high and sealing may not be proper as well. So life is poor and operation is energy inefficient operation. So basically how contact is behaving in the lubricated condition, that we are trying to understand through this small clipping. So I mean two surfaces are being shown in relative motion. So if suppose one surface we are saying this is a piston ring, this is cylinder liner, so a lot of asperities are there and lubricant is available here. Now basically what is happening here, contact is taking place asperity to asperity, then welding is taking place and debris are being created. So concern is that if suppose this lubricant is not available, it is not separating the surface, then huge metallic contact will be there, or at various places welding of the metals will be there, and in order to break that welding to have the motion, a lot of energy will be consumed. So depending on surface topography of the piston ring and cylinder liner, friction may be more or friction may be less. And if sufficient film thickness is there, then surfaces will be separated and gliding is very smooth and friction is very less. Normally what happens in the engine, thin lubricants are being used so that power loss should be less inside. Viscosity of engines, viscosity of oil is very less. Now what is happening, if viscosity is very less, then metallic contact chances will be high, asperity to asperity contact will be high. So in that situation normally additives are used in the lubricant, and these additives they react over the surface, and one layer, mono layer of the additive will be formed, and once asperity contact will be there, then this layer will be protecting the metallic contact and friction will be lesser. So this is the theme, I mean how friction is coming in the picture between cylinder liner and piston ring. Now another point is for improving the fuel efficiency. If you see the I mean points where researchers are working right now, they are focusing. So these points are smart engine design itself, if at all it is possible. Another point is material selection, because at the interfaces wherever contacts are taking place, material combinations should be such a way that friction should be lesser. And another point is surface modification. Let us modify the surface itself so that friction should be less. So this is the best option right now. The reason is modification of the surface, it can be done because here chemical or lubricant is not involved at all. Though chemical or whatever lubricant we are using, this is blood for the machine, but it is poison for the environment and human being. So issue is that uh, huge quantity of lubricant application, it should not take place. It should be discouraged. It's fine. And another point is that eco-friendly lubricating oil or additive should be created, and that should be used in the engine. So right now, though all 4 points are equally important, but our talk, our discussion will be there on surface modification. So basically how to modify surfaces we'll be talking, and through modification of the surfaces how we can reduce the friction we'll be talking, and then one demonstration will be done by modification of piston ring surface, how fuel saving was done and how emission it was controlled. So we are coming to functioning of the piston ring. So functioning of the piston ring, uh, top compression piston ring role is very crucial because it is a barrier. One side hostile environment is there, huge temperature, huge pressure, and another side lubricant is there. So lubricant should not go to the combustion chamber, and combustion product should not come to downside, else efficiency of engine will go down and lubricant life will be very fastly deteriorated. So role of the top compression ring is very important, and its profile, how it is touching to the cylinder liner, is equally important. So our focus will be on design of profile of top compression piston ring. If we see piston ring, normally typical, schematic diagram, it is being shown. So two ends of the piston ring where coming supposed to be connected, but space is given. So various type of joint we are looking, various type of end joints are possible. So a square cut it is being shown, simply piston ring it is coming and it is kept inside the piston, and then it is opened and then it is pressing to the cylinder liner radially outward. Another angle cut it is there, and similarly C and D, if you see square step cut and round step cut joint it is there. So this end design is very vital, because if combustion product it is there, so there is a possibility that combustion product may come through this end and it go to downside. So proper sealing it is needed. And another point is that when motion it is taking place, dynamics is happening. So dynamics of piston ring is very complex, and when end it is not properly designed, then noise may be chance, fluttering may be the chance, and functionality will be poor. So end design of the piston ring is very very vital. Though cost of the piston ring is very very small, very minor thing it is there, but function it is doing very advanced function is there, very important function it is doing. Typical dynamics of piston ring, it can be seen like that. So point A, if you see, basically what is humming operation is taking place, motion it is taking place. So when piston ring it is brought and it is kept inside the uh, piston itself, then once it is released, then it is going radially outward and it is touching the cylinder liner. So this is one loading, and another loading is there when humming operation is taking place, reciprocating motion is taking place, B point, then there is a relative motion of the piston ring inside the slot itself, that groove which is given on the piston itself. And third motion is that secondary motion it is there. Basically B point it is associated with the primary motion, and C point it is associated with the secondary motion, tilting action it is taking place. So basically if you see, dynamics of the piston ring is very vital and very complex it is. So all type of motion are possible. So issue is which type of profile should be cut on the piston ring so that an energy efficient engine should be developed. And another point is that what is happening if primary motion is taking place, then what it is creating, what it is guiding inside the engine, and if secondary motion is there, what it is dictating inside the engine. So in order to understand these 2 points, uh, I mean further 2 3 slides will be discussing. So here, consumption of the lubricating oil, if secondary motion is not properly designed, and secondary motion, it is being guided at the interface of the piston ring and uh, cylinder liner. So if contact design is not proper and secondary motion is taking place, then there is high chance that a lot of lubricating oil consumption may be taking place. So right now you can see these 2 figures. First figure, it is a primary motion. If contact design is not proper, then how oil from sump from bottom it is thrown to the combustion chamber, and then high temperature is there, evaporation is taking place. And second point is that if secondary motion it is active and proper design of the contact is not there, then scraping will be poor and a lot of lubricant will be thrown in the combustion chamber itself. So here profile design of the piston ring, it is a very vital. Now, another point if it can be seen, if sealing at the cylinder liner and piston ring is not proper because of not proper design of the contact, lubricant properties have not been selected properly, then there may be scope of blow by, means directly combustion product is going to sump side. This is very dangerous. Efficiency of engine will go down. And another point is that if suppose certain, I mean, gases are striking to the secondary piston ring, then it may follow the path as indicated in figure V, and this is called blowback. So blowby is responsible for inefficient engine, and blowback, it is responsible for fluttering of the engine, noise will be there. So proper design of piston ring, I mean, it is needed. And here also, if you see this figure, oil is blowing, oil is going out through the cut end of the piston rings. So how this end should be designed so that proper sealing should be there and energy efficient engine should be developed. Now certain profiles have been shown here, and top piston ring profile we are looking 3 cases. TDC, it is top dead center. BDC, it is a bottom dead center. Now AH is film thickness in horizontal direction. So if profile is like this, then how film thickness is varying? So from top dead center to bottom dead center, film thickness almost it is a flat. And if profile it is like this, and then how film thickness is varying, it can be seen that at middle film thickness is more, at top dead and bottom dead centers film thickness is less. And if profile is like this, basically it is barrel shape profile, then how film thickness is varying? So here film thickness is very less, and there is a scope of metallic contact, asperitic contact at top dead center and bottom dead center. So proper profile of the piston ring, it is having vital role on the functioning of the engine. Normally it has been seen in the market, flat surfaces of piston ring people they are using. So that is not good. It is not giving a proper result. That will be sharing in other slides as well, some results. So here issue concern is that if proper design it is done of the piston ring, then there is a scope to save the fuel, to make engine energy efficient, and at the same time we can save lubricating oil as well. So here this profile is important, but here this profile is also important, whatever groove it is there and piston ring this profile, because combustion product may follow the path, this path it may follow like that. So issue is that here also sealing will be there, because lubricant, if it is existing here, lubricating film it is existing here, then sealing will be there and combustion product won't be going down. So both profiles surface of the profile, it is very vital in functioning of the engine. Now, how to create profile, how to modify surface texture of the piston ring, that is the issue. So nowadays emerging areas are there. From nature people are copying various ideas, and that is called biomimetics. So here attempts have been done to use concepts of the nature and implement on the surface, put on the surface of the piston ring, and make it energy efficient and control emissions as well. So here biomimetic concepts have been used, and it will be discussed. Basically what is happening, uh, very important saying is that lotus effect. And if you see water droplet, if it is coming in the contact of the lotus, so situation is like this, and there is no wettability, surface is not getting wetted. So what is the reason? So for lubrication point of view, if suppose small drop of the lubricant is coming and it is touching to the piston ring and it is touching to the cylinder liner, so we want this type of situation, the way water is touching a lotus leaf, or we want that complete wettability should be there. Of course complete wettability we want, because if it is not wetting the surface, then lubricity won't be there, lubrication won't be there. So issue is that merely here, I mean, one surface is there and this surface is not allowing water should wet the surface. So reverse way it is possible. We can modify the surface where a small drop of the lubricant can be kept on that and it will stick properly and it won't be easily removed. So that type of situation can be created. So basically this is one concept from the nature itself. So here lotus effect if we call, and let us try to understand. Since long we are knowing, and it is good saying that lotus, it is there in the pond itself where dirty water is there, but lotus is not getting soiled. So what is a reason? A reason, it is not some divine reason. A reason is surface texture. So earlier ACM was not there. Hardly 20 or 25 years back, when scanning electron microscope it was invented, and people they started looking the surface texture of lotus under ACM, then they observed surface texture of lotus, it is like this. So basically small portion of this lotus, it has been taken and it has been magnified, and this has been seen through ACM. So what is surface topography of lotus, which is bringing the characteristic of water coming in contact and becoming spherical. So issue is here texture it is there. So small dimples, protrusions are there outside. So these protrusions, when water it is coming sitting on the surface, then air pockets are there in that protrusion. So basically water contact angle will be very large and wettability won't be there, and even if little air will blow, water will go out and lotus leaf will be clean. So reverse way it is possible on the piston ring or cylinder liner. So let us see how it can be done. See, we can copy ideas from the nature. So here nature is good engineer. So how nature has designed her own machines, because human beings, because animals, living things are machines of the nature. So here we are looking one giant body of a fish, and this is shark fish. So issue is that how drag reduction takes place on the surface skin of the shark. So how nature has created, how nature has designed that surface. So we are looking here one ACM small skin has been taken of the shark fish, and under scanning electron microscope that surface has been seen. So here skin it is looking like this. So here basically canal type of this type of feature it is present on the skin of the fish, and within canal dimples are present here. If you see here small dimples are there. So issue is that if let us try to understand what is engineering behind this surface, then it is quite clear. if this type of surface is there, we can interpret it that if micro channels are there, micro canals are there, then mixing of the water won't take place. So at the skin, there won't be turbulent flow, only laminar flow will be there. And another point is that dimples, very tiny dimples have been provided inside the micro channels. The meaning is that slip will be created, means slip will take place and drag will be lesser. So nature has designed this surface in order to minimize the friction on the giant body of the shark fish. Why not this surface we copy on the machine elements, particularly piston ring? It is fine in order to make low friction. So here attempts have been done to copy certain features from nature, and then experiments have been done in order to assess what is the role of these features over emission and over the fuel saving. So here micro structured surfaces for underwater application, it is tailing, slip will take place and laminar flow will be there, so drag will be less. Here in our laboratory at IIT Delhi, we are conducting certain experiments. So here fish we have taken, and this fish skin we have observed under ACM. So it can be seen, this is a local fish available in the local market of Delhi. So its skin, if let us see, so how small skin has been taken and its texture, how it is appearing, it has been shown. So this is ACM photograph. So what is interpretation? How drag it is reduced on the surface? Basically, here micro channels are there, so water is flowing there. If same type of design, at least we manufacture copy on the surface, then friction will be lesser. That idea is coming from the nature itself. So what it has been done? First, mathematically, equation of the surface has been created. And equation of the surface, if you see how it is created, x direction and y direction, two directions have been defined, x and y. So here this distance and this distance, if you see repetition of the feature, it is there. So it has been measured using surface profilometer, and then equations have been created, and these equations, this is y-axis, this is z-axis, and here this is x-axis, this is z-axis. So equation we have created of the surface, and this equation we have taken and mathematical modeling has been done in order to understand whether friction is reducing or not. So analysis is revealing drastic reduction in the friction. Then issue is, let us fabricate and test. So attempts have been done to fabricate it, though proper manufacturing facilities are not there, still certain limitations are there, but we tried to copy it on the surface through laser surface texturing technology. So here what is happening, I'll try to explain. Basically one droplet it is being shown, and this droplet, if it is coming to the contact of this surface, and it is making very high contact angle. So basically it is not weighting the surface, like lotus effect we have seen. Now another point is that if surface, this spherical droplet, it is taking this type of shape, then contact angle is becoming like this, so it will be weighting. So what it has been done, we have created surface, and this is surface created by us through laser. So here contact angle, one drop we are putting, that contact angle is 28.5, and here surface modification has been done, and then contact angle is 22.9 and 19.7 degree. So issue is that if this surface we are creating on cylinder liner or on piston ring, then wettability will be better and less quantity of lubricant is needed, and friction will be lesser. But here friction will be more. So basically from nature, surfaces have been copied, and particular surface it is given, and lubricant need for lubrication, it is reducing. Now another surface can be seen here, 36.8, it has been So if textured unlapped surface it is there, 36.8 degree, so contact angle is more, so it is a poor surface, it won't be working properly. Now after doing this surface feature, then another point is that profiling should be also done. So piston ring profile, and this profile I am talking of top compression piston ring. So various single continuous profiles have been considered in this investigation because mathematical modeling has been done. So you can see cubic, cycloidal, exponential, parabolic, quadratic, all these profiles are easy to cut because once it is programmed through CNC, and it is very easy to cut. The reason is patch up of surfaces are not there. One single equation is given, then it can be cut easily. That is why it is called single continuous surface profile. So we are looking when these profiles are brought on the surface of the top piston ring, then friction per contact, if you see here, it is compared here. So we are looking that if you see the variation, basically 2 Newton plus minus 2 Newton, the meaning is, I mean, humming operation is going on. So in that sense, you can say minus. Minus means it's not other way, direction change. It is basically, it's fine. So here we are looking certain profile that is showing us very low friction, and that low friction it is shown by if you see the profile by color. Can you identify what is the profile? Parabolic profile, it is giving maximum friction, and if you come to the downside and if you see the profile exponential profile, it is giving lesser friction. So basically if you see the difference in the magnitude, 2 times difference we are getting. Now what happens in market, if you see piston ring profiles, these profiles are flat normally, hardly any shape it is given. So issue is, I mean, to make the point that if proper profiling is done, then huge saving can be done, huge reduction in the friction can happen. It's fine. So here we are looking particularly in this context that exponential profile is much better than other profiles under investigation, and these are single continuous profiles. There may be scope if patch up of the profiles we are preparing better, I mean friction reduction surface may come, but issue is that manufacturing issue, and another issue is that it may wear, because after a lot of I mean expenditure, profile is being cut, and then after short time when humming operation is taking place, it is rapidly wearing, so it is meaningless. Means profile should be easily cut, as well as it should be stable against the wear, it should not wear fastly. It is fine. So these profiles have been cut and then implemented, and first issue was that let us measure friction in primary motion. Normally in engine, based on the literature whatever we have compiled the knowledge, primary motion, it is mainly responsible for fuel consumption. However, secondary motion, it is mainly responsible for lubricating oil consumption. So there is a issue how piston ring profiles should be designed, how dynamics should be modified, so that compromising should be there, optimization should be there. It is fine, because lubricant also it is a very important, it is a very costly, and we don't want that it should go in the combustion chamber and burn. It's fine. So here one rig has been designed, and the purpose of this rig is to understand the function of primary motion. So here secondary motion is not there, and if you see the rig here, what is happening, reverse way it is operating. Reverse way in the sense cylinder is humming and piston is stationary in this design. The reason is we want primary motion only. Because if piston ring we are allowing to hum, then primary and secondary both motion will be there. So we won't be able to understand which motion is doing what. It is fine. So here primary motion has been, I mean, made objective, and cylinder it is humming. So the concept of the rig can be understood like this. If you see the picture, so here what is happening, lubricating oil, it is being dropped from the top, and compressed air, because this is a rig, motorized rig, so here firing cannot happen. So here combustion product, how it has been created, it has been created by sending compressed air inside. So compressed air, if you see the path how it is following, so compressed air is coming here, from here it is coming, and then hole it is there, and gases air it is coming here. So this is the path, and lubricating oil it is coming here. And sometimes what happens, if you want to create soot contamination inside, then contaminant we are aiding in the lubricant itself, because aiding contaminant in the air, little problematic it was there. So that idea was there to add contaminant in the air itself, but it didn't work. So lubricant is having contaminant and equivalent to soot, so that type of situation has been created. Only thing is that what is not created here, temperature rise, it is fine. Pressure we are controlling, because compressed air pressure we are changing accordingly. I mean combustion product pressure, I mean, can be simulated here. So in this view, I mean it is shown this system, lubricating oil system, compressed air system, and another view you are looking, and here one sensor it is there, capacitance sensor, and this is for measuring the film thickness. When humming operation is going on, then we are measuring the film thickness through this sensor itself. Now downside it can be seen here, yes, type of load cell is there when it is humming. So basically cylinder it is humming, it is going up and down, and piston ring and this system connect, all these are stationary. So here whatever friction it is coming at the interface, that is being transmitted this signal to the microprocessor or computer. And similarly here film thickness is varying when it is humming. So various type of designs, right now whatever I have discussed, I mean single continuous surface profiles, and I mean biomimetic surfaces copying on the surface. So we try to, I mean, copy those surfaces on the piston ring and try to measure film thickness and friction as well. So I'll be sharing certain results. So all the profile of piston rings have not been modified. Only one profile has been modified here, and this is the profile. Other profiles of the piston ring are identical. Whatever from market we are purchasing, same profile we are using. Only single profile has been modified here. It is fine. Then what is the consequence of that will be looking. So very closer view you can see of the rig here. So here basically this is a cylinder, it will be humming, and these are the guide rods. So here this is the capacitance sensor to measure the film thickness. It can be seen from here. If you see here, pressure 0.4 megapascal and RPM 100 RPM, because this is a motorized rig, inertia forces are very high, so we started running at lesser speed. So only top, right now I discussed that only top compression ring we modified the profile single. And what is happening, friction ring pack total friction we have measured, because total 4 rings are there, but we modified profile of out of 4 only 1 ring. So here what is happening, roughly we can see 90 or 100 Newton friction force it is coming when complete ring pack it is there without modification of the profile. And single profile has been modified, then same operating condition, and we are getting, if you see, roughly here 70 or 80 Newton. So we can say about 20% reduction in the friction it is taking place, merely modifying only profile of single piston ring, not all. It is fine, and this is a very drastic change, drastic reduction in the friction it is taking place. It is fine, and if this friction reduction is taking place, then it has been tried to understand how much lubricant is getting saved. So what happened, this motorized rig is used to study the friction force in primary motion as well as wear characteristic of the feature whatever we have imparted on the piston ring. Means if suppose particular texture it is created, particular profile is created, so it is wearing or not. So it is very easy to do experiment using motorizedly. So that has been done, and observation is in front of you. About 20% reduction in the friction we are getting. Now what happens? So this profile has been cut on the piston ring, and then that piston ring has been used in an engine. So the result would like to share. So very small engine has been picked up, 3.5 HP power engine running at 1500 RPM, testing time 40 hours. So what results we are achieving? It is a very interesting result. It can be seen. 10 hour slot engine was run, because at a stretch we don't want to run the engine. The reason is frequent start and stops will be there. Then proper testing of the engine will be there, because continuous if it is running and once lubrication is there, proper film formation is there, then damage chances will be less. So it was decided frequently let us stop and start. Then it is decided 10 hours interval will be there. So one day will be running 10 hours, so then after 3-4 days we'll be running 10 hours, like that. So total 40 hours run it was done, and it can be seen here that particular textured surface, profiled surface, vital reduction in the fuel consumption it is taking place. And together within 40 hours run it was observed about 4.5% fuel saving it was there. Another point is that effect of profile on the noise of the engine. So here engine is there, noise has been measured at this location, front, this is left, this is right, this is back, this is top. So here what is happening, we can see here left, this much difference we are getting. So 95, it came down to 90, and similarly other places a significant reduction in noise also it is taking place. So what is the reason behind reduction in noise? It can be guessed. One can say that proper lubrication has been taking place. That's why proper sealing it is there, proper lubrication is there, that's why noise it is reducing. So fuel saving is there as well as noise also reducing. So double benefit it was recorded, though intention was there in the beginning only to reduce fuel consumption. And another point it can be seen here, wear of top piston ring, conventional piston ring, when 40 hours run it was there, so it was 0.039, that is gram, where by weight it was taken of the piston ring. And when it was textured, particular profile it was given, then drastic reduction in wear has happened, and we can say 300% reduction in wear has taken place. So wear is also less, friction is also less, fuel saving is there, as well as noise is also less. So importance of contact design can be understood between piston ring and cylinder liner. Another point is that when certain profiles were taken without the texture, then what is the result? Parabolic and exponential profiles have been taken, and this is the top piston ring, and this is at middle, and this is exponential profile it is here, and top compression piston ring. So three cases have been discussed. Basically intention to discuss is, see, this is the surface micrograph has been taken, and here exponential profile we are looking, and this is parabolic profile, this is the middle, this is the bottom. So here what is happening, this surface and this surface you compare. So exponential profile, whatever in the beginning surface is there, exactly same surface was there, there was no wear at all. And if let us see in terms of numbers, top compression piston ring, when design of this piston ring is changed, only top compression piston ring, what is happening? See, conventional profile available in the market, 40-hour run, 80 milligram wear was there. And when this profile is modified, then for the same hour, 60 milligram wear was there. And because of this profile modification, whereof other rings also reduced in comparison to a conventional one. So very, I mean, strong influence is there on the contact when profile we are changing, and very significant performance parameters are changing and getting improved. Now fuel saving, if you see, this is not with texture, this is only with profile. So with profile, parabolic profile, which is available in the market, piston ring, and this profile, exponential profile, we machined, we manufactured on the surface. So about 4% fuel saving it was recorded. So basically, here it can be correlated, means 20% reduction of the friction. What is the meaning? 20% reduction of the friction means 4% fuel saving. It's fine. So that type of equation we have developed, but this equation is not valid for all cases. It may vary engine to engine. Particular engine we have taken and we have done it because when modeling it was done, so that time also boundary condition of this engine was implemented in the modeling, and accordingly data was presented and discussed right now. So here another engine was taken, and this is 10 horsepower engine. Earlier engine it was 3.5 horsepower. So let us try on big engine. So big engine, then it was thought, why not to do with the biodiesel? It is fine. So here certain conventional profile and another name is given in order to hide the feature. So here what is happening, we are getting efficiency improved with the new piston contact, new piston face. So though it is a marginal, but 3 to 4% efficiency it is improving. And similarly here, brake specific energy consumption also it is getting improved. Here hydrocarbon emissions also it was analyzed. So issue is that when piston ring profile is changed, what is happening, why emissions are reducing? That point we are trying to discuss, we are trying to understand. So here if you see biodiesel, hydrocarbon it is, and what is happening here, if you see here hydrocarbons are lesser with new piston ring profile. Similarly, it can be seen here carbon monoxide and many other NOx. So all these things are drastically reducing at high power, brake power, if more, then better result we are getting. Similarly, carbon dioxide also drastic reduction we can say here. Now about 20% reduction it is taking place. So intention to tell right now that when we are changing the profile, uh, taking a lesson from the nature, then we are finding that cutting the profile is difficult. First, we'll try to understand the profile. Let us copy that profile, measure its attribute, and then because it is a micron size, sub-micron size, so machining it is a very difficult. So normally very precision machining is needed, and this machining we are doing using lasers. It is fine. And after this, when laser operation it is done, basically whatever texture, whatever shape it is being created on the face, so strain hardening is taking place because vaporization of the material it is taking place and strain hardening is taking place. So surface is becoming hard, and it is helping one way. Wear it is reducing. If hardness of surface is more, then wear will be less. So proper heat treatment, if it is done in addition to creating the surface, then better result, it is achieved. So here, what we have achieved, let us summarize it. So friction force reduces considerably with textured profile of piston ring in comparison to conventional profile. Means market we have taken the profile, and same profile we have taken a certain shape we have copied, fish type of shape, whatever it was, dimple, that we have copied, and result is in front of you. 4% reduction roughly we are getting in the fuel consumption, and about 5 to 10% noise reduction is also taking place. It is fine. And about 4.6% fuel saving is recorded. And Another, if you see, the finding is a reduction where drastically it is reducing. 100% where it is reducing. Top compression piston ring only modification is done, and noise level 5 to 8 decibel it is reducing with the dimples. And then another two points, when profile we are changing, we are not doing any dimpling, any texturing or any other attributes we are not providing, merely we are changing the profile. Then the result is like this: exponential phase profile of top compression piston ring is causing about 10 to 15% reduction in the friction force, and which is further leading to 4% saving in the fuel. So next concept is that let profile and surface texturing together will marry, and let us see what influence is coming. So right now we are looking that noise it is reducing. Lubricant consumption also we have measured, that is marginally reducing 1.5%, but that data right now not here it is. And fuel saving 4 to 5% we are getting. And another point is wear is reducing. So wear is less means clearances will be increasing at slow rate. And if clearances at the contact increasing at slow rate, then it is good. Reliability is better, life will be better of the contact. So intention is right now to say that if contact design we are doing properly and friction minimization we are doing properly, so without changing, without doing anything, without using any chemical, without harming environment, we are doing great thing. Emissions also it is reducing. We have seen many cases. So all the front, I mean win-win situation it is there. Merely change of the geometry. No lubricant change, no additive, nothing, only geometry is being changed. So basically we can guess when geometry we are changing, direct understanding is that contact sealing is proper, friction is reducing, but why emission is getting reduced? What might be the reason? We can guess. I mean, I was thinking why emission it is getting reduced. Basically, I understand combustion process marginally it is getting modified because of that. So this is the reason, as per my understanding.
Maybe the lubricants is not coming up in combustion chamber.
Lubricant, see, if lubricant is coming in the combustion chamber, first thing that we don't want that should happen.
No, we don't want that oil is reduced to come upside. Then automatically combustion will be better and emission will be
Yeah, that's fine. But another point I would like to tell you, if suppose lubricant is not coming in the combustion chamber side itself, fuel it is getting I mean, burned and not it is burning properly, that also it is a source of emission. So here two thoughts are there. Lubricant, of course, it may not be coming, and it is not coming. The reason is that if lubricant is coming in the combustion chamber and it is breaking, then irritation will be there in the eye. So of course we have assessed, because saving of lubricant it is taking place 1.5%. So of course lubricant may be going but less. And another point we are understanding that somehow combustion process is also getting modified marginally, something like that. That guess we are doing, but we can substantiate that right now. It is fine, unless one should see with the camera and making wall combustion chamber I mean transparent, and how ignition is taking place, all those and correlation should be done. Then only certain thing can be said. It is fine. So I think that I mean my I mean findings are over. I have shared with you, and now I am ready to I mean take some questions. So
hello.
Yeah. Hello.
I am from YMCA University of Science and Technology, Faridabad.
Yeah. Please welcome. Yeah.
I want to ask one question.
Please.
You are saying there is a lot of saving by using dimple profile as compared to conventional thing.
Yeah.
Now you have shown a slide in which you are saying you have tested for certain hours, like 30 hours, 40 hours.
40 hours. Yeah.
But actually, in the case of vehicle, the vehicle is running for many years.
Yeah, sure.
And a lot of wear and tear takes place.
Right, right.
So how long lasting will these savings will be achieved?
Yeah, I will say because see, one portion I said that motorized rig we are having. So where test we do on motorized rig, 2000, 3000 hours we run there, and a very hostile environment we create because dust, dirt, etc. we keep on adding in the lubricant, and there we have assessed that where it is not taking place, stable profile is there. And another point is that long duration testing on real engine we cannot do because I mean economic issues are concerned. We cannot I mean sustain expenditure of running engine. I mean less than 1000 or something like that. But we are relying based on our laboratory test, motorized rig test, that wear is not taking place. It is quite stable. If it is fabricated using laser and hardening is done properly.
What will the clearance between piston ring and cylinder or
That clearance, see, normally what happens, clearance basically film formation, lubricant film is getting formed between cylinder liner and piston ring. So how geometry is there at the contact, it matters, because for better lubrication three conditions are needed. First condition is that at the contact, I mean there should be physical ways, means some shape convergent geometry should be there at the contact so that lubricant can go inside. And second condition is that there should be relative motion at the contact. So relative motion it is taking place, cylinder liner is stationary and piston ring it is humming, so motion is there. And third condition is that one medium which should have viscosity should be interposed between mating surfaces. So medium is lubricant. So if three conditions are being met, then lubrication chances will be there. Why chances I am saying? Because when reciprocating motion it is there. So reciprocating motion, normally if you see reversal of motion it is taking place. So film rupture it will take place at top dead center and bottom dead center. And another point is that if speed is very high, of course there is lift of speed, means lubrication will prevail at that speed. If that speed is reaching and proper film formation it is there inside, then we can say that this is the order of film thickness, and that you can say clearance. Film thickness, minimum film thickness is itself it is clearance. If suppose film formation is not there, then there is no clearance at all. Metallic contact will be there.
what will be the life of the piston ring, sir?
Life,
sometime.
life of the piston ring, what we have tested based on our I mean thing, 1000 hours we have tested in our laboratory. So where it was drastically small, means 200% reduction it took place in comparison to conventional, and perfectly fine, stable. Whatever feature it was given, that was stable.
How can we ensure that a piston ring is damaging on piston?
Actually, what we are doing physically, we are visualizing. Suppose in the beginning we are measuring its profile, texturing we are measuring, it is fine, and we are weighing, and then dimension, radial and axial we are measuring, and all dimensions and weight we are measuring, and then we are firing, putting inside the rig or inside the engine. It is fine. So what is happening after running? Then we are taking it. Then I mean very carefully we are looking, washing it, and then same location we are measuring is all the features, and we are comparing. Weight we are measuring, dimension we are measuring, profile also we are measuring, and finish also we are measuring and comparing. So if it is not deteriorating much in comparison to original one, then we'll say that health is fine. Piston ring it is not wearing. If suppose drastic changes are coming, then it is wearing.
Piston rings wear and tear depend on a lot of things. Is dust entering inside with air.
Lubrication.
With air also is there.
Yeah.
Then also is wear and tear is involved. Like that, lot of reason can be there.
See, my understanding is that friction is the main nuisance. If suppose we are mitigating or minimizing the friction, then it is fine, because main wear it is happening because of the friction. It is fine. If suppose friction we are mitigating, so what we are doing? We are replacing solid friction or dry friction by fluid friction. It is fine. So if suppose fluid it is coming at the interface, and fluid friction is less and film it is there, so issue is that wear won't take place, or very small wear will be taking place. So life will be longer. It is fine. And particulates, suppose soot it is there, etc. So in the system, engine system, filtration is there. And another point is that if tiny particles somehow passing and it is going there, and film thickness it is existing at the interface, then damaging will be less. Unless particle size is bigger than minimum film thickness, then it will be blocking that contact. So if filtration is there and proper film thickness it is taking place, then life it is significant, reliability it is there. So as per our, I mean, whatever limited study we have done, I mean, we are getting a positive result. Of course, the way, I mean, he has asked, I mean, extended duration test should be done to establish and to declare that things are very successful. It is fine.
But maybe and that this is yeah, for your expectation. There's a lot of investment is required.
Yeah, investment it is required, and see, I mean, particularly fuel consumption and labor charges and all those things are there, and frequently stopping, opening, measuring all these things.
Availability of test bed and
it's very complex.
A lot of things is there.
Means very comprehensive study can be done, systematic, and what is doing what. First study itself in our mind is that we have understood the role of primary motion. What is the role of secondary motion? So another rig let us design where only secondary motion should be there, no primary motion, and see the role of that. Then we'll be able to understand primary motion is doing this, secondary motion is doing this. It is fine. Then how to design the contact so that both the issue at a time should be, I mean, addressed. It is fine. So that type of thought it is there in our mind, and we are in process of, I mean, planning some project. If we'll get fund, we'll carry out it. It is fine. But initial whatever investigations we have done through modeling, through experiment, encouraging results we are getting. Any other doubt? Any question?
Hello. Hello.
It's not
Sir,
audible.
my question. Sir, my question is crank case dilution is helpful in lubrication system?
I'm sorry, it's not audible. Please send message. Your voice is not audible. Please send some message, or you send email. Your question?
Sir, there is a question in micro challenge surface texture or change its profile from parabolic to exponential, which one is more effective?
So,
Like
there is a question on chat box.
Yeah.
In microstructure.
In
micro channel surface texture or change the profile from parabolic system, which one is more effective? See, I would like to tell you, both at a time we have not done. Texturing only we have done, means channel with both at a time we have not taken, means profiling and texturing together we have not done. So profiling only we have done, one study has been done, and another only texturing has been done. Third study, profiling plus texturing, it is left out, that we have not done it. But our understanding is that based on whatever results we are getting, better result will be getting when both we are marrying, both concept together we are using.
that is crank case solution. Is crank case dilution is helpful in lubrication system?
Crankcase dilution is helpful in lubrication system.
See, dilution, which way you are saying? Do you mean you are changing lubricant, less viscosity lubricant you are using, or you are saying that dilution it is taking place because of water it is coming in the lubricating oil or somewhere like that? So if water it is coming, water is very dangerous. So that is, I mean, if it is present in the lubricant, then that is not favorable, and lubrication will be bad. If dilution you are saying, what I understand, dilution means viscosity should be lesser viscous oil you are using. So lesser viscous oil, it is preferred because less viscous heat dissipation will be there. In the churning, lesser loss will be there. So energy efficient system will be there. But at a time, we have to see that also, film formation should be there at the interface between piston ring and cylinder liner. So much thinning of the lubricant, it is not preferred. And thinning, if you are doing, then thinning should not be done using water in that context, dilution.
Dilution because of temperature, rise of lubricant.
See, if certain additives nowadays being used, I mean, in engine oil, if you see, the polymeric additives are being used, other additives are being used. The issue is that film thickness, thinning should take place, but we want film thickness. Thinning is taking place means we are not expecting that metallic contact should happen. So film thickness should be there, viscosity should be less. If viscosity is less, then temperature rise will be less. So that situation we prefer. So that's why additives are being used, and a lot of polymeric additives are being used in the lubricant to impart this property. Means temperature rise will be less, viscosity will be less, as well as film is existing, film thickness it is there. So of course, I mean, dilution in that sense, if you are saying, then it is good, but up to limited, I mean, condition, because film formation should be there. You are diluting such a way that asperity contact is taking place, then that is not preferred. So there is optimization. Any other question?
Sir, what will be the effect of atmospheric temperature on lubrication system?
See, issue is that when we are using lubricant, we are pouring lubricant in the crankcase in the beginning before firing the engine. Then atmospheric condition, it is their temperature, atmospheric condition. But once engine it is running, huge heat generation it is taking place. That time, if suppose you are measuring some temperature, then that temperature is very high. So there is no role of the atmospheric condition then, because some temperature is very high, and that at that temperature, whatever oil viscosity is there, with that viscosity, oil is entering in the lubrication system. So as such, there is no role of atmospheric condition, atmospheric temperature. That's fine. Any other doubt?
Can we pick this slide, sir?
Pardon?
This PPT, can we get this PPT?
Actually, certain issues we are in process of patenting.
Okay.
So certain points I can remove that, but anyway, you have copied it, you have taken photographs, so already it is in your domain. So you may take that. It's fine.
Then I will take.
You can take it, or I'll provide you, no problem. It is fine. So any other doubt, any other question? Is it okay?
Film thickness of lubricant, what's next question is came at last?
Film thickness of lubricant.
Which model is considered
Right.
like Baru?
See,
Borrowed model.
Baru's viscosity model and Reuland's viscosity model, these two models are very popular. Rheological relation when we are doing. So here if you see the lubricant right now, engine lubrication when we are talking, then contact is conformal contact between cylinder liner and piston ring. Contact is not so much concentrated contact, conformal contact is there, and for conformal contact situation, density of the lubricating oil, it is not getting much influenced with increase in pressure and temperature. However, viscosity is a strong function of temperature. So in the model, for conformal contact model, when we are using Baru's viscosity model or Reuland's viscosity model, then result won't be varying too much. But when pressure is very high, if more than 0.25 gigapascal, then that time Baru's viscosity model will over predict the coefficient of friction, or we can say viscosity over prediction will be there. Then Reuland model is accurate model. So in our modeling, we have used Baru's viscosity relation, rather we can say Vogel relation it has been used. Eta is equal to eta 0 e to the power minus gamma t minus t0. Any other query? That's fine. Should I wind up? It's okay. Okay. Thanks. Thanks to all of you for your kind presence.